Okay, so this is almost the same thing that we did with the last topic, except this time we're not just writing empirical formula, but we are writing the molecular formula, the formula that gives the exact number of atoms in one molecule of this organic compound. So we're given the same information, percent by mass, values for each element, and we're going to follow our little path to find empirical formula. So empirical formula is going to be our first stop. And then once we find empirical formula, then we can find the molecular formula. Okay, so let's fly through the beginning. We have carbon, we have hydrogen, we have oxygen. In this sample, 62.58% is carbon by mass, 9.63% is hydrogen by mass, 27.79% is oxygen by mass. And so we assume 100 grams to convert this directly from a percent to gram amount. 27.79 grams of oxygen. And I use molar mass to convert from grams to moles. 1 mole of hydrogen, and here 16 grams of oxygen is 1 mole of oxygen. I'll now have mole amounts for each element in this 100 grams of sample. So I end up with 5.210 moles of carbon. I end up with 9.555 moles of hydrogen, and I end up with 1.737 moles of oxygen. Now, I find the smallest mole amount between these three. Oxygen is present in the smallest mole amount, so I divide all of the mole amounts by the smallest. This will give me a mole ratio of 1 for oxygen. The mole ratios for all the other elements should be greater than or equal to 1, since oxygen is present in the least amount. So 9.555 divided by 1.737, 5.50, and for carbon, 5.21 divided by 1.737, I get 2.99. Now remember, I told you all that there'll always be very close to some number. Here, I can't say that this is close to 6. It's always going to be very close within 1 or 2 decimal places. So this is actually, I need to go with 5.5 here. Here I can go with 3, and of course this is 1. So the issue is, I can't yet have empirical formula because this is a decimal, it's not a whole number. But remember, if you have 0.5, just multiply everything times 2. If I multiply that times 2, I need to multiply this times 2, and this as well. 5.5 times 2 is going to be 11, and 1 times 2 is going to be 2. So my empirical formula is going to be equal to C6H11O2. Now, is this my molecular formula? Well, how do we find molecular formula? ALEKS gives us this equation. Molecular formula, the way we're going to find that is we need to take the molecular molar mass and divide it by the empirical formula molar mass. So what is the molecular molar mass? It's given in the problem. So here, the molecular molar mass is 230.30 grams per mole. The empirical formula molar mass is the molar mass from the empirical formula. So if I take 12.011 times 6, add it to 1.0079 times 11, and add that to 16 times 2, I will have the molar mass of this empirical formula. So I end up with 115.1529 grams per mole. I should get some multiplier. So when I take 230.3 divided by that answer, 1.9999. So just like the mole ratios, this multiplier should also be very close to some number. It's very close to 2. So what do I do with that 2? Well, I use that now to find the molecular formula. I take this 2 and I multiply all of the subscripts in my empirical formula by this multiplier. So that means that this needs to be multiplied by 2. This one does, and that one does as well. So what I'll end up with is C12 H22O4. That is my molecular formula. And if you actually find the molar mass of this molecule, you should get 230.3. Let's try it. 12.011 times 12 plus 1.01 times 22 plus 16 times 4. I get 230.35. So we're off just a little bit, but that's just due to rounding error and some of the values we used for our molar masses of the elements, for example, and when we determine our molar mass of the empirical formula. All right, so this is our molecular formula, and we just follow the same steps to get to the empirical formula, and then we use this equation right here to find the multiplier we need to use to convert from empirical formula to molecular formula.